Next, we move into the discussion where we've already seen some questions posted. I'll just take them one by one and feel free to add anything. You have in the chat, you have the link to the Slido. Fernando, is it okay if I take them one by one, or you have another plan? You have more experience with Alice webinars, clearly.
That's perfect, Laurie.
Let's just go for them. So I'm just sorting them for popularity first. The most popular one is for David Sabon. Why was the BEV truck heavier than the diesel truck? Usually the BEVs, FCEVs are allowed more payload than the ICE trucks. So there's an exemption in place.
Laurie, can you hear me?
Yes, very well.
Right, yes. So the rules in the UK are that there is, we can carry 44 tons on 6 axles. Prior to electric vehicles, we could carry 40 tons on 5 axles. So the extra axle on the tractor unit gives you that ability to carry the extra 4 tons. The OEMs, all except for Volvo, are not providing 6-axle tractor units, battery electric tractor units. So they're only providing 5-axle tractor units, for which the old regulation was 40 tons. They can now carry 42 tons because they have a special exemption. So the way that the loading works, if you load your 44 tonner, you can carry 28 or 29 tons as a uniformly distributed load. If you load a 42-ton truck with 5 axles, the most you can get on it with the uniformly distributed load is 22. So there's a payload loss of 6 or 7 tons for going to the 5-axle BEV. There is a 6-axle version. Volvo does a 6-axle, a 3-axle tractor unit that can run in the UK. But because of the extra axle, it's only able to carry 3 battery packs instead of 5, which means its range is very short. And so it's not really a viable solution for any sort of long distance. It is good for short shuttle journeys at maximum load. So I hope that answers the question.
Thank you, David. I'll give the opportunity to people to respond if anyone feels like it, to add to this or to comment back.
I would like to comment.
So, yes, please, Jacob.
Even if you have an extra weight allowance, in the future you will still be competing BEV against BEV. So if you cut out 3 tons versus another BEV, unless the regulation is very strange, that should still be a benefit.
Okay.
Yes, I think that's absolutely right, Jakob. The problem that we've got at the moment is that the industry needs to transition from diesel to electric, and in order to do that, it needs to be profitable. That nobody's going to buy the next 200 trucks in their energy transition if those 200 trucks can't be made to operate at least at the cost of diesel, if not less. So if the costs are higher, the fleets will not transition. That's the problem. In the long distant future, the comparison between EVs is the right thing, but just at the moment where we're trying to get the fleets to transition, then the only way it's going to happen is if a particular operation is cheaper than, or at least no more expensive than doing it with a diesel. And that is really the problem that the weight penalty and the time penalty introduce, because what they mean is that for every diesel, you need to have, 1.25 EVs or 1.1 EVs or whatever it is. It's 10% more, it's 25% more. And the details of that are complicated because they depend on the operation. They depend on what you're carrying, how much load you're carrying, what distance you're carrying, where you can charge, what the topography is, you're going up and down hills, what the traffic is, how the drivers perform, all of those things. And they really complicate the whole story. The bottom line, however, is that you need more trucks and therefore more drivers that you have to pay for, and the cost of logistics goes up if you have these penalties in place. And if the cost of logistics goes up, then the industry cannot transition because they can't afford to do it unless somebody pays. And that somebody has either got to be the shipper to pay the carrier more, and there's little indication that shippers are willing to pay a large amount more, or it has to be transferred onto the consumer down the supply chain, in which case that is going to require some sort of legislation to encourage government to do that. But if we don't have legislation to carry the additional costs, we can be almost sure that the transition can't happen, because companies will simply not buy trucks that are going to be more expensive to run on their existing logistics. I hope that makes sense.
Right. I don't see any hands up of people who want to respond. If you'd like to respond, please raise your hand and we'll give you the floor. Let's go to the next question, which was anonymous again, but perhaps that's all in the system. We only focus on freight operations. Wouldn't the economics for all improve if we also included general mobility, that is buses and road trains, or maybe even cars? So this wasn't directed at anyone in particular, but I think maybe Jakob has looked at light vehicles also. Maybe you can comment on this.
Yes, I can comment. The economics would absolutely improve if other traffic would also be using ERS. So you have a approximately fixed cost per distance, and then you divide that cost by the energy you sell. So the more sales you have, the lower the cost per user. The question is then the incentives. So if you build it for the heavy trucks, who else has an incentive to use it? And there, the dominating incentive structures are largely unknown for passenger car traffic, especially. For all commercial traffic, you can assume that they will be TCO driven. For car traffic, it's unclear. My own suspicion, based on, but it's only a suspicion based on research, is that about 15% of energy to cars would come from ERS. That would be largely concentrated on a few cars.
Thank you. Clear answer to the question, I think. So there's a new one on top in the question list. So people are starting to vote, which is great, because you start voting, then we can see what are the most important questions. Public authorities struggle to finance maintaining the infrastructure. So just the maintenance issue with the infrastructure. How to find the resources to move forward? Let's see, maybe Håkan can comment on this from the AFI perspective. So it's about the infrastructure maintenance and how to find the resources for the road, from the road authorities or from the ministries to move forward.
No, I think I wrote to Jacob. The investment at large is not that high from a larger scale deployment. The investment isn't. Again, you have to move very far from your own pocket money, and then it makes a lot of sense. I see Michael want to add.
Yes, please.
We've recently talked and got insights, and maybe Jacob's term of the insurance could be a way forward, that we have see different funds, pension funds and others looking for investment opportunities, also including the European Investment Bank and other pension funds and so on. So that could fill the gap actually when there's a clear economic case and business case, as we have seen, to fill in for the initial investment and different forms of setups we've seen on infrastructures. Nevertheless, I see challenges in everything regarding planning, administration, approving, and so on. So there we have on the different levels, at least from a German perspective, I see a lack of skilled staff, but we see it in various administrations. So that could be a challenge, but maybe finding the funds and the money, if there's a clear political signal, should be possible.
Thank you. Okay, we had Ted raising his hand, and then I don't know which order, but we had Fernando and David also. Ted, please go ahead.
Exactly. I think if there is a business case, there will be funding. There is quite some funding available for decarbonization, and instead of investing in, I don't know, other resources, if it's efficient, it could be get funded.
Yeah. Okay. So my experience also in the Netherlands, we have the European Investment Bank also having already been looking with interest. We have the recycling scheme for the truck charging that will start in 2026, which gives also hundreds of millions. For the Netherlands, only 500 million a year. So there are funds which should go into infrastructure also, but mainstreaming this with maintenance is a distinct possibility. Then I don't know which order it was, Fernando or David, but Fernando, please, you go ahead.
It's okay. My comment was that hearing all of you, I think it's somehow evident that ERS is a very good solution. So then I was wondering why it does not seems to be taken up. And I think Michael came with some ideas, but I would also like to understand from your point of view, which are the key aspects why this solution is not taken up more prominent.
Well, we will all have something to say about that. Now, before we go into that, Fernando, let's first finish the responses to the previous question, if you don't mind. So, Jakob and David, David had his hand up for the previous question about infrastructure costs, I think, and Jakob also. So let's finish that one, and then we go to Fernando.
Yes, thanks, Laurie. I think the fundamental here is that it's actually cheaper to do ERS than it is to do static charging. And there are a number of reasons for that. But the result is that it's easily affordable by private financing. You can easily install ERS and make profit with private finance by selling electricity to trucks, just as a static charging station sells electricity to trucks. The advantage of ERS is that the grid connection costs are less. You have a smaller number of large grid connections. The utilization of your charging assets are much higher. So the chargers along the ERS are in use all the time. The vehicles are all cheaper, and the consequence of all of this is that the electricity costs can be less. So you can have significantly lower electricity costs, and Jakob said 25 cents, I think. Our calculation is you go up to about 30 cents, with the profit margin between 30 cents per euro cents per kilowatt hour and about 10 or 12 cents per kilowatt hour that you can buy the electricity for. With that profit margin, you can easily pay for the ERS. Let me make one other point, and I think this is an important one. That is that if you had an ERS system, in the UK, it would use something like 10 to 15 gigawatts of power continuously to power the UK road freight system. You would have an asset which you could use to modulate electricity consumption in a very flexible way. And you might expect to be able to switch on and switch off up to about 2 gigawatts of charging capacity, because the vehicles can just all be charged at a slightly slower rate or a slightly higher rate. That flexibility of electricity consumption is hugely valuable to the electricity supply system and can be sold at great profit. So there's lots of money in the system, which means that it's highly viable from an economic point of view, more viable than static charging. You don't need to put aside all that land. You don't need to set aside all those grid connections, and you have much higher utilization of assets. So it will definitely work. The problem is that we need to have permission from the road authorities to do it. And it's permission that's needed, not money. Thanks.
Thanks, David. Jakob, you still had your hand up. I don't know whether you wanted to add to this discussion, or we can go to the next question.
Yeah, so the question was, why haven't we invested already, essentially? And then I think that a key dynamic there is that it's scary. You need to build very, very large deployments before it becomes before you can recoup the money. If you build 100 kilometers, nobody will use, or almost nobody will use your ERS system. It's just too little. And you also shift the investment, even though the total investment is smaller, you do need to take that investment earlier. Also a challenge.
And I would also say it's about lock-ins, distracting lock-ins so far in the discussion. Lock-in on the transport system without looking at the energy system benefits, as David said. Lock-in in the hydrogen system and the e-fuel system without looking at how to fully and smartly electrify quickly. So I think there's also a novelty about this, which is genuine. It's not that even though the researchers have been occupied with this and there have been pilots, it hasn't been at a tried and tested state of implementation that the car electrification has. I mean, if you look at how car electrification has proceeded in the last 5 years, it's obvious we've learned a lot and enough to also build it out towards freight. And I think this is less the case for dynamic charging.
I showed some maps with different colors, different roads in Europe, and on the high traffic roads, we're looking at return on investment, or we're looking at the net profit after about 6 years, I think. And that's from the day you start building and you gradually take things into operation, not that you finish everything and then you wait 6 years.
Okay, so we will continue with this. The next question, I think it's the billion-dollar question, like what would be the best strategy, conductive or inductive, for a large deployment across Europe? It's very close to Fernando's question, like, guys, if this is such a good system, then why isn't it yet there? And if there is a strategy, what is it? So let's go into that one. Who can I give the floor? Jakob, you still have your hand up, or is it a new hand? I don't know. I can keep asking you, but if you keep your hand up, you'll be the one answering all the questions.
I'm thinking about the competition rules in the beginning. So how to address that question? I don't want to touch it.
Okay, who wants to touch it? So the question is, what would be the best strategy, conductive or inductive, for a large deployment across Europe? David and
let me comment. The system which is the most tested and therefore can be deployed quickest is undoubtedly the overhead contact lines. So if you want a quick deployment, that's the system that Michael mentioned, the overhead contact lines. That's the one which has been tried and tested and is ready to go. The other systems are less tried and tested and ready to go at scale and need some development and testing work. So I think that's the sort of fundamental point. There are issues about construction costs. All of them will need the same amount of power, near enough. Some are a bit less efficient than others and they need a bit more power, but near enough, everybody needs the same amount of power. And that is a system of, something like what I showed, that is a big substation at a key location, a private wire along the road, and then charges regularly spaced every kilometre or two, feeding electricity into the road. The cost of that will be the same, and that technology will be the same in pretty much all cases. Maybe a slightly different voltage or whatever, but near enough, it's the same thing. So your question comes down to a few other issues. We have a problem in the UK with low bridges. There's challenges with overhead contact lines for low bridges. It's possible to do it, but there's not much space between the top of the truck and the bottom of the bridge soffit, and that causes some challenge. So there's lots of different issues. My personal preference is conductive, because I think the efficiency gain of conductive systems is well worth having. They use less energy, and then it would have to be either in the road or overhead contact lines. And as I've said, in the UK, we have problems with overhead contact lines for the bridges and other things. So I'll leave it to you to draw your own conclusions from that information.
Thank you, David. Håkan had his hand up also. You're muted, Håkan.
So my preference is, of course, very clear. And just to answer on what David mentioned, I think in order to talk about maturity of a system, we need to define the system. Wireless, or our technology, has been implemented in more countries than any other, on more different types of vehicles than any other, and has been in real commercial operation. It's a definition, I think. But also, to put it, look on a broader case, I think the big challenge we have here is that in comparison to the static charging, you can build 1 megawatt charger, and then then a politician can happily cut the ribbon. In our case, it's more complicated to really introduce an electric road system. You need a higher investment, and you need to do it in most cases in Europe on public road, which is state-owned, and there you have a little bit of a hen and egg issue, and a very slow-moving organization that need to take the decision. And this is, I think, one of the main challenges, and this is why the European Commission activities are so important, to make them aware.
What could be the best strategy, Håkan? Because you're in this group discussing the AFIR, you're discussing the evaluation of the current AFIR and the realignment of the AFIR. I mean, a strategy to roll this out should be part of the discussions, I believe. How is this going in your group?
I think the main where we need to be sharper, and we as supporting organizations of electric roads, is to focus on the challenges which Jacob points out. I mean, how can we reach the long-term targets? It's so easy to say that we will build megawatt chargers, but when we look at the horizon of 2040 to 2050, of course, the magnitude of infrastructure becomes, almost, you can almost laugh at it, right? Because there will be so many charging posts along the roads, and I mean, just the need for charging or parking places will be a issue. So I think that's kind of the key to make the decision maker look a little bit further in the trajectory.
Laurie, you're muted.
Okay. Laurie, we cannot hear you anymore. I don't know. It's okay. I don't know. We haven't done anything, Laurie. So then maybe it's just because we are arriving to the end of the session. So I saw there are a few additional questions that are remained unanswered. So then we'll try to connect. And then what I suggest is that I can then conclude this session today. First of all, I would like to thank Laurie that brought this topic into our table and actually coordinated and arranged with the speakers. I would like to, of course, thank you, Angelo, for the organization, and also Paula for the support of this webinar. in particular for the David, Michael, Jacob, Ted, and Hakan for the insights. I think that's very interesting, all the insights you got and the results of the research, but also on the implementation projects that you are running. I like to mention the clear answer from David that ERS is much cheaper solution. So I think that's very interesting. However, the solution is still not taken. So from that side, from an Alice point of view, we want to share that together with our sister platform AirTrack on road transportation, we are now updating the long distance freight transport roadmap. And with this roadmap, we will advise the European Commission for future research and innovation and also additional activities. And of course, electrified road systems are part of that roadmap, and this webinar will bring insights that we will definitely use in that roadmap. Additionally, this starting point today, it's also an invitation to all of you that are maybe interested in going deeper, in trying to push for this solution, to come back to us. And for that, what it's important is that you let us know. So then you contact us through email, or better, even you answer to the questionnaire that was in the invitation and shared by my colleagues. Based on that, and if we get enough interest, we will continue the discussion within Alice, and then you will hear from us accordingly. So I would say again, thank you to David, to Michael, to Jacob, Ted, and Hakan, and Laurie. And without any additional thought and insight, just invite you to get and stay tuned. And I see Laurie cannot anymore be here, so no worries. Everything worked very well until now. So, and we are on time. So I only wish you all having a very good, nice afternoon and evening. Thank you very much.